Hello everyone, so today I'm back with another differential equation. So this question is similar to the questions that I've solved previously, but then this question will not be solved using just variable separation, because if you send this y to the other side, then and even if you take y common, then what you will have is x minus y. So if there are two different variables here, so that way you cannot separate variables for this question. So that means that we'll be having to follow the linear differential equation method. So first of all, let's eliminate y from this side. So it'll be 1 over y square dy over dx plus 1 over y is equal to x. Is this in the standard form? No, the coefficient of dy over dx should be 1, but then here it is 1 over y square. So I think around a month back I've solved a question very similar to this, where we suppose whatever is here as some other variable, and that way we will change it into the standard form. So let's suppose let 1 over y is equal to, let's say, n. Okay, so now let's differentiate this thing, both the left hand side and the right hand side, with respect to x. So what we will get is, this is a new step, and this is a new step as well. Let's change the color. So dy to the power minus 1 over dy, first of all, the chain rule, of course, then dy over dx is equal to dn over dx. So now the answer to this would be minus 1 over y squared times dy over dx is equal to dn over dx, isn't it? Yes, it is. So now what we can do is that let's send this minus to the other side, so we will have this. And if you are to look over here, then you'll see that 1 over y squared times dy over dx is present here as well and here as well. So let's substitute the value here. So the value would be minus dn over dx. So let's substitute this value over here. So let's go to another page, and then let's write it as minus dn over dx, and then of course the value of 1 over y is n, so let's write it as n is equal to x. Simple. So now we can see that wait, so what we can do is we would want to make this side positive, the coefficient of dn over dx as plus 1, not minus 1. So what we can do is take minus common from this side and send it to the other side. So what I'm trying to say is, yeah, minus plus, yep, is equal to minus x. So this now is in fact in the standard form. The coefficient of dn over dx is 1. We have gotten just the term containing x on the right hand side, and then minus n is over here. So not a big difference. So now what we can do is try to find the integrating factor, but before that let's find p dx. If you don't know what p is, then please check out some of my other videos where I have explained it. I think the title of that video is linear differential equation, so it's very clear over there. So is equal to, so over here p is minus 1, integrate that with respect to x, of course, what we get is minus x plus c. So yes, and finally integrating factor is the integration e to the power integration of p dx, so that is minor x. You don't need to mention the integrating coefficient, or the integrating constant c over here, because at the end we are going to write it. So you can just write it as e to the power minus x. So this is the integrating factor. Now we are going to multiply this equation by the integrating factor. So this is another step, e to the power minus x. Wait, let's create space for solving the entire question. So it would be dn over dx minus n is equal to minus x times e to the power minus x. So I hope there is no confusion till here. It's very simple. And now there can be some confusion, but then I'll try and make it very simple for you. Is equal to minus x times e. So some of you might be having problem understanding how we came from this step to this step. So if you are to open this term, just this term, the term on our left hand side, using product rule of differentiation, then you will exactly get what is in the previous step, this. So I just try to use concept of derivative here while solving this differential equation. If you don't believe, then you can just open this term using the product rule, and you will simply get what is in the previous step. So now let's send this dx to the other side and integrate both the sides. So dn times e to the power minus x is equal to integrating minus, let's pull it outside, x times e to the power minus x dx. So as you know, derivative and the integration sign are just antagonistic or opposite in nature, so they cancel each other out. That means on the left hand side we'll have n times e to the power minus x is equal to minus remains as it is, and then we are going to apply the product rule of integration over here, and we are going to use the Eilert rule. And since x is algebraic, it means that it's going to get differentiated, and the next part, e to the power minus x, will be integrated. So let's have a bigger bracket, x e to the power minus x dx. It's just a formula, and let's have a curly bracket. Oh, this curly bracket looks pathetic. Yep, this looks better, not perfect, but still dx over dx, and then another integration sign. So e to the power minus x dx, curly bracket, dx, big bracket. This is n, not x. It looks as if it is x. Yes, so now beginning of another step. So that way what we will have is n times e to the power minus x is equal to minus x times the integration of this is e to the power minus x over minus 1 minus e to the power minus x over minus 1 dx. Let's close the bigger bracket and let's move to the next page. So now it is going to be n times e to the power minus x. I hope I'm not going too fast. Minus x times e to the power minus x plus minus times minus is plus, so plus e to the power minus x over minus 1 plus c. Or what you can do is you can take the c outside as well, as it's just a number. So wait, yeah, let's do that. Wait, let's do, yep. So n times e to the power minus x, so is equal to x times the minus multiplies inside the bracket. So this minus multiply this minus multiply this minus would be plus. So plus e to the power minus x minus c. Or what you can do is, since c is just a number, you don't have to multiply this minus with c. So let's, for our convenience, let's write it as plus c, and then 1 over y times e to the power minus x. I just replace the value of n as my 1 over y, that's the original value, is equal to. Now what you can do is, first of all, yeah, let's write this once again so that there is no confusion. Yep. So now what we can do is express this as 1 over e to the power x. So 1 over y times 1 over e to the power x, this is a multiplied sign, x over e to the power x plus 1 over e to the power x plus c. Now let's take LCM over here and here. So what we will have is 1 over, sorry if the noise of the dogs is disturbing you, it's not my dog, but then it times disturbs us. So e to the power x times c. I just took the LCM. This e to the power x cancels this e to the power x, and the final step, we're just moving towards the final step, so it would be 1 over y is equal to x plus 1 plus e to the power x times c. So let's take y to this side and let's express it as 1 is equal to xy plus y plus cy times, or yeah, e to the power x. So there you go. This is the final answer to this question. It's not very difficult once you understand the concept that I've talked about in my previous videos as well. I hope you understood how to do this, and of course hope to see you in my next videos. Thank you.